Let's say we randomly select 2 out of the over 200,000 scores from the AP Statistics exam from 2016. Let's say then we take the sum of those 2 scores. Let's find the expected value and the standard deviation, or the mean and the standard deviation for the sum of those 2 scores. We'll call them x1 and x2. So here's the mean. So I've got 2 random variables, and I'm interested now in combining them by adding. So the mean of the first random variable, well, we already calculated for an individual score, the expected value is 2.9. So for the first random variable, its mean is 2.9. For the second random variable, its mean is also 2.9, and we'll add them. 5.8. Not particularly sophisticated. The standard deviation, though, is a little bit more sophisticated. So the standard deviation of the sum of x1 plus x2, that's really what I'm interested in, but you can't add standard deviations. It's not 2.8. You add variances, but you can only add variances if your 2 observations are independent of one another. Well, we can argue that here by the 10% rule. So understand, for the first score, x1, its standard deviation is 1.4. I'm going to square that to make a variance. For the second observation, its standard deviation is also 1.4. And I'm going to square that also to make a variance. Now I can combine them by adding if these are independent random variables. Well, here's the argument that I'm going to make. Because if you take 10 times this sample size, 10 times 2, well, that's 20. That's certainly less than or equal to 206,563. So by the 10% rule, I can act like x1 and x2 are independent of one another. By the 10% rule, we can act as if these 2 scores, as if x1 and x2 are independent. So I have my variance, I have my second variance, I can add them. Then to turn it back into a standard deviation, I need to take the square root. So that's where we'll go to our calculator. So we'll just take the square root of our 2 variances. So that's the 1.4 squared plus another 1.4 squared. And that will give us our standard deviation of about 1.98. There we go. So instead of looking at the sum of those random variables, what if we calculate the difference of x1 and x2? Well, no problem. The mean of x1 minus x2, well, I'll start with the mean of x1, that's 2.9. And I'll use the mean of x2, that's 2.9. And I'm looking at their difference, and clearly that makes 0. So there is nothing different, though, with the standard deviation. To find the standard deviation of x1 minus x2, understand that I'm still combining all of the variability of x1 and all of the variability of x2 in a linear way by subtracting. So the bottom line is I still have to combine the variances by adding, not by subtracting, by adding. So here, it's actually exactly the same answer. It's the 1.4 squared plus the 1.4 squared. I'll take the square root of that, and you get exactly the same answer, 1.98. We already did that. So a little bit more interesting is considering the mean. So let's say that I have 2 randomly selected scores, x1 and x2, and let's find the average of x1 and x2. So it would be helpful to think about what an average really looks like. We take those 2 values, we add them and divide by 2. But mathematically, that's the same thing as taking 1/2 of x1 plus 1/2 of x2. So what we really have here is a combination of 2 random variables, x1 and x2. It's a linear combination because all we are doing is adding, and we are also affecting both of those random variables by multiplication. So this is a linear combination of these random variables. So understand the mean of 1/2 x1 plus 1/2 x2, literally what this says is it's going to be made up of half of x1's mean plus half of x2's mean. So literally, here's half of x1's mean plus here's half of x2's mean, and shockingly, that gives you 2.9 again. So things are a little bit more interesting when you look at the standard deviation. The standard deviation of 1/2 x1 plus 1/2 x2. So again, what we have to do is combine variances. So notice x1 has been cut in half, so that also cuts the standard deviation in half. So to find x1's new standard deviation, when I multiply by a half, I have to take its old standard deviation times a half, but I need to turn that into a variance. We add variances, not standard deviations. And then I'll do the same thing for x2. x2's standard deviation has been cut in half by the multiplication. So there's the old standard deviation times the half. I'll turn it into a variance by squaring it. And of course, to find the standard deviation, then I need to take the square root of that combination. So we'll put that in the calculator and we'll be in good shape. So here, we'll take the square root of, and I'm going to use some parentheses here. I'll just do 0.5 times the 1.4 plus same thing. That 1/2 we'll just write as 0.5 times 1.4. We'll close our parentheses and square that. We'll be in good shape. So our standard deviation is right around 0.99. There we go.